All right, finally, we are going to be relaxing our two-dimensional assumption, looking at three-dimensional aerodynamics. This is a third assumption other than inviscid and incompressible that doesn't make any sense in practical scenarios because we are living in a three-dimensional world. What does it mean by looking at a flow field that's strictly two-dimensional? Well, in reality, this assumption means the following. It means that we are looking at a very elongated body. Elongated not in the streamwise direction, but in the spanwise direction. We are looking at an elongated body that does not change as you translate along the body. Right? For example, if you're looking at a two-dimensional airfoil, what does it mean? It essentially means that you're looking at a very elongated wing, a very high aspect ratio wing. And you're looking at a part of the high aspect ratio wing that is away from the root and away from the tip, right? So, for example, if you look at section 4, right, on this particular wing, it may pretty well satisfies some aspect of the two-dimensional assumption, which is that as you translate along the wing, as you move from section 4 to slightly away from the center line, the flow field doesn't change much. That's what we mean by two-dimensional aerodynamics. However, as you look at not in the middle of the span, but if you look at the tip or the flow around the wing body junction, the flow is no longer two-dimensional, which means the flow field is going to change a lot as you move a little bit more towards the tip or a little bit closer to the fuselage, right? So in this kind of flow fields, we can no longer assume things are two-dimensional, and we have to look at the three-dimensional aerodynamics. So these four modules really build on top of each other. In particular, module 1 is the most fundamental for all of these. There is no way you can understand the module 2 or 3 or 4 without understanding module 1, the two-dimensional, incompressible, inviscid aerodynamics. You can more or less assume module 2, 3, or 4 are independent from each other, right? I mean, there are things that depend on each other, but the majority of module 4 does not depend on compressibility, for example, because we are pretty much talking about incompressible three-dimensional aerodynamics. There are subtleties about compressible three-dimensional aerodynamics, but these are more advanced topics. That is, we are not going to be focusing on in this class.